Okay, we're moving on to activity 5.3, Storytime Again. So it's called Storytime because you are going to come up with a story that could be represented by these equations. So the directions say take turns with your partner telling a story that might be represented by each equation. Then, for each equation, choose one story, state what quantity X describes, and solve the equation. If you get stuck, draw a diagram. So we're not in a classroom. You're not going to be working with partners. So what I'm going to ask you to do is come up with your story that could be represented by each equation and submit it. And then I'll give you the story I came up with. Just maybe as a suggestion, if you're having a hard time thinking about this, anytime I see a story, I see an equation with decimals and I have to do something like this, I think about money because, decimals translate easily into money, cash money. And then B, I got B twice there. My formatting leaves something to be desired. But always when I see fractions, I think about pizzas or bottles of water, something along those lines. So that might help you. So anyhow, go ahead and come up with your story for each of those and submit. Come up with A first and submit it. Okay, so like I said, whenever I see decimals and I have to do something like this, the easy path seems to be thinking about it in terms of money. So I'm going to say, let's say, Mary went to the store and purchased 2 items that came to a total of $12. If one item was 70 cents, that's where my 0.7 comes in, how much did the other item cost? Okay, so the other item is represented by X in the problem. And then I'm supposed to solve it. So if I have 0.7 plus X equals 12, and I want to get the X, 1X by itself, I'm going to subtract. Oops, not. Kind of fudge that. 7/10 minus 7/10 is 0. That just leaves the X. And then 12 minus 0.7. I got to do some borrowing. 10 minus 7 is 3. 11 minus 0 is 11. So X is going to equal 11.3. So the other item must have cost $11.30. All right. Now let's look at B. B is a little trickier. But like I said, think about this. You could think about this in terms of pizza. You could think about this in terms of bottles of water, cookies, something that's easy to think about in use fractions to envision. So this means 1/4 of some number is equal to 3/2. And another thing that might help you here if you're trying to visualize this is think about 3/2 as a mixed number. It means 1.5. So 1/4 of something is equal to 1.5. So see if you can come up with a story for that. Okay, so let's see. 1/4 of something is equal to 1.5. So I could say 4 friends decided to split a box of cookies. If each friend got 1 1/2 cookies, how many cookies were in the box? So how many cookies were in the box is my unknown. There's 4 friends, so each of them gets 1/4 of the number of cookies that was in the box, and 1/4 the number of cookies in the box is equal to 1 1/2 cookies. So that's my story I'm going to tell. And then I'm supposed to solve it. So if I have 1/4 of x is equal to 3/2, and I want to know how much 1x is. So I want to make this 1x, so I can think of it as dividing both sides, but divided by 1/4 or multiplying by 4, either one. If I divide that by 1/4, I just get 1x. And if I divide 3/2 by 1/4, that's the same as 3/2 times 4/1. I can do a little simplifying. 4 and 2 can both be divided by 2. And I end up with 6/1, or 6. So the number of cookies that were in the box is 6 in the solution to the problem. Oh, that's not even on the, sorry. There we go. So I had to recap, since that wasn't even on the screen. Divided both sides by 1/4. I did my arithmetic of 3/2 divided by 1/4 over here, and my solution was x equals 6. And like I said, we're all going to have different solutions to this one.